Hello everyone and welcome to my class CE432 Traffic Engineering, and today we're gonna switch gears a little bit to a different topic. It's an easy topic, and we were gonna talk about how we collect traffic data. So let's go directly and jump to my PowerPoint presentation, and let's talk now about how do we do some counts. What's the meaning, what's the different kinds of traffic counts and traffic studies that we do. It's going to be a short presentation, and let's go ahead. So for traffic data, huge part of traffic engineering is to collect data. To understand anything going on in the road, we need to know what's going on, and data is the thing that gives us this idea. So why do we need traffic data? For different reasons. We want, number one, we want to know what's going on. So it's a comprehensive description of what's the current state of roads and highways. If you remember, we talked about something called demand. So we want to know what is the current state of traffic demand on facilities, how much people want. When I say here demand, it's the request or the requirement for transportation. People want to go from one place to another. So it's the current traffic demands on facilities, and also we use this, remember in transportation engineering, guys, when we talk about future planning. So we need data now so we can able to find the projection or the different predictions for the future. The problem with traffic engineering is actually data collection. It's a very massive task. It needs lots of money because we need equipment, sometimes people, and it needs some time to collect data. Cars on the road are something that's indefinite, meaning that you can always find cars on the road even in the middle of the night. So we need to capture that. So sometimes we need to have long hours of data collection. Right now, with the technologies we have, this task is much cheaper, especially when cameras were invented, but still it's one of the hugest tasks, and it's big budgets in traffic engineering studies is dedicated to traffic counts. In early times we used to use people, but right now with technologies, and I'm gonna show you this week one of the technologies we have in class, which is the traffic camera, and this is one technology we use, and it helps us a lot to reduce the amount of time we need to do the analysis and also do the get the raw data to collect that. So why is it difficult? Well, as I told you, it needs money. We need to observe and quantify behavior of road users in real time, and that's a problem, and that's one of the big issues in traffic engineering. What's going on right now in real time? So over the large system, for example, like Beckley, I won't say Montgomery. I know this slide is kind of old from when we were in Montgomery. How many roads? How many intersections? Well, look at Charleston, look at Beckley, look at Morgantown, look at New York. Let's look at Shanghai and Delhi. Well, it's crazy. Every road is different, every lane is different, every highway is different, every intersection is different. So it's a huge task, and the bigger your study area is, the more you need for data collection. We need days. I remember my first project ever once after I graduated had a huge 3-month long of traffic counts. We counted, you name it, we did count it. We counted vehicles. It was a whole downtown area study. We counted vehicles, we counted travel times, speeds, occupancy, pedestrians, lots of pedestrians, buses, you name it, we did everything. It took us 3 whole months to count, to do this count and have some kind of analysis for the whole downtown area. So huge amount of traffic engineering budgets, the money goes towards data collection. So what are the applications? You get the data, okay, then what? So number one, we need to figure out what's going on right now so we can manage the physical system. Let's say you want to do some maintenance, you want to know how many cars are going there. So if you have some kind of diversion routes, you will be able to do that successfully. So it's for roadway, traffic control, detectors, sensors. If you want to maintain the system, this is also one thing that we need to put into consideration, how many people are using it. Let me give you another example. If you probably remember, you can see this a lot when there's maintenance, we put a traffic signal, which is temporary. Sometimes it's over a truck. Well, to be able to design this traffic signal, we want to know how many cars are coming in each direction, so we can control this temporary traffic signal. So it's an important thing for us to understand how many cars coming from each direction, especially in the peak hour. Number two, you want to do something called time trends. In other words, we want to figure out the problems before they occur. So for what's the future needs for traffic volumes and traffic demand, and also crash data and traffic data. And traffic safety is a big issue in traffic engineering. We need data for that. We need to know, okay, how many crashes happen there? We need data for that. So sometimes data collection is a big task. Number three of things of the applications we use is we want to understand the traffic behavior, especially in the future. If you remember in transportation class, guys, we talked about model choice. And then back to traffic engineering, want to know the travel times, and we'd also do some kind of parking studies. Everything happens with the driver behavior, and we want to capture this driver behavior, and we have counts, and we do lots of data collection for that. It's a treasure of knowledge for engineering, but I have to stop here just for a second. Right now, another technology that you might have heard about, the big data and the Internet of Things, and now our cell phones and smartphones collect our data all day long. If you're on Google, then Google collects your data, and lots of applications collect our data, and part of this data is used for traffic engineering purposes. And to give you an example, if you just go to your maps, if it's Apple Maps or Google Maps, and you want to go from one place to another, then you want to put your destination, and the application will tell you if there is a better route because there's congestion. It's going to tell you how much speed you're going to have on every road. How was this collected? So simple. They have their own algorithms and computer software that collects the data, have it somewhere in the cloud where it analyzes for every road and different users, and the data collected from every single phone. They know their speed, they know if they're standing still, and it gives you an idea what's going on in every road, and this gives you this red routes or orange or green routes that you know. So now big data is collected now using our phones, and that's the newest big thing in traffic engineering. So as you can see, it's a treasure of knowledge, and that's why there's a problem with privacy right now. So let's get back here. And since we use, I just told you the word algorithm, so AI is working there. Lots of computer software that we use to simulate traffic and try to figure out what's going on. So data is used to calibrate these programs. And the word calibration, you can hear a lot in traffic engineering. Calibration is just kind of fine-tuning and fixing the traffic models on the computer, so you'll be able to model it as best as possible. So you want to calibrate the relationships, and a very simple relationship. Remember when we did this kind of equation? Let me bring my pointer. Remember these relationships when we had speed and we calculated the flow? Well, all this comes from data. Remember these points we had in the previous presentation? This comes from data. If you have more data, you're probably going to calibrate, meaning that you're going to create another kind of curve. So data is used always to calibrate any models, if it's mathematical models and now with computer models as well. So perception reaction time, for example, this is, let's say the perception reaction time we have now is 2.5. But we collected more data and we found that people are drinking less now and driving less. So it's getting less than 2.5. So we can do this calibration, fixing and tweaking and fine-tuning your models and your values. Also for headway, spacing, and any kinds of models, if they're mathematical, computer models, are usually calibrated to reflect current situations. So you have new conditions in the road, new cars, better cars, electric cars. So we need to put this in consideration, and it will definitely affect your model. Another very important thing about data, we do this a lot. Let me put this word here: before and after. Lots of studies in traffic engineering is before and after, meaning that, let's say that you, give you an example here. If you remember the construction that happened in Berkeley in the last few months, when they were creating the new driveway that went throughout the city, near the mall area in Berkeley, we can go ahead and just figure out how good it is before and after. So we collect data, let's say collect data of travel time, or collect data of delays, or any type of data, or how many people are using this new corridor now. So before and after tells me how good we are. Did the level of service go up and down? We don't need only to do that after it's constructed. We can do that in the models. In the computer, like I showed in the computer model we had last time, when we say, okay, I have a new signal I want to install, and I want to figure out how does it work just on the computer. Data will tell me that. So if I want to assess the effectiveness, improvements, potential impacts, so here improvements, things that's already done, potential impacts, that things that are something in the future that are potentially going to work. So we do something called follow-up studies. That's a very, very important thing in traffic. You did a bridge, you did a new highway, and you want to follow up. Is it working or not? Did we spend money good or in a bad way? Do we need to do some other options? Let's say we put a signal. We do sometimes need to do an after study to figure out is it going to work, or should we tweak it a little bit more or improve it a little bit more. For example, if you have a new development, and this happens a lot when we have here a new development, and we create something called a TIS, Traffic Impact Study. I'm going to talk a lot about this traffic, because most probably 90% guys, if you're going to be working in traffic engineering as traffic engineers in any consulting company around the world, you're going to be probably doing these TISs. It's amazingly easy. Usually you do a TIS, like I've done tons of TISs. TIS is a traffic impact study. Let's imagine that we're gonna build a new mall. I always give Montgomery an example because it's that city, like or that town, and you wanna build something. Let's imagine that we're gonna build a new Montgomery Walmart. So we need to have something called a traffic impact study to assess the impacts of this new development. It might be any kind of development. And do the 4 steps that we did in transportation: trip generation, distribution, model split, and assignment. And we figure out, okay, this new development, how much traffic it will have on the road. And do we need to do some mitigation measures, which means that do we need to do some changes in the traffic network around this new development? Will we need to add some signals instead of stop signs? And this is called the TIS. It's an amazing topic, because you guys, if you work as traffic engineers, you might make good money out of it, because any requirement now, any development needs a requirement, a traffic impact study to have all the permits in the city. So imagine a new city, a booming city, a developed city, you're gonna have tons of traffic impact studies. And again, you need now the system. You want to evaluate the system, figure out what you need. So sometimes data, it helps us to evaluate the data. So data is the foundation of traffic engineering, guys. Without this foundation, the structure falls, like you learn in your structures and your concrete classes. In traffic engineering, if the data is wrong, then you're going to build on wrong stuff, then you're going to probably have wrong conclusions. Okay, talking about data, and let's talk about what are the different studies you guys, if you work as traffic engineers, you'll be probably doing. These are the different studies and different types of data, so we can consider the studies or data. I'm going to go very fast here. We can do volume studies, and this mainly depends on counts. So here you can see here this road, you want to know what's going on this road in the peak hour. Do we need to add a lane? So we need, first of all, we need to know how many cars are passing by every single peak hour. Speed studies. And speed studies are, we want to also know what are the speeds. Remember also this curve that we did, speed and density. Speed is an important thing because speed is also relates to density, which relates to something called, remember this guys, level of service. So we use the speed studies in several things. One thing is traffic safety, because safety is worse when we have higher speeds or we have different speeds. We use a lot in the highway design. Remember the design speed? Speed regulations, and this is important for the political decision makers to know about speeds. Another kind of studies we do a lot, especially in cities, when we do delays. How much delay? Because also delays relate to level of service. The more you're delayed on the road, the worse level of service you get. And also part of the counts that we do, not counts, it's data collection that we do are travel time, where we have a car, we go into traffic and we have a stopwatch and we measure the travel time. The delay is the difference between the time you spent already on that trip and the optimal time, the time you should be doing that. If you check any of these morning news channels, local channels, when they talk about the traffic, they tell you, okay, now because of this crash, the travel time between Charleston and Beckley, instead of 1 hour, is going to be 1 hour and 30 minutes. So my delay is the difference, 30 minutes. And these give you the quality of service, which is the level of service, and also related to it, how much congestion we have. Density studies, and it's also related to level of service. Again, I told you before, density is not an easy thing to collect directly. We need to use the word occupancy to indirectly collect the data. So here, the loop detector, probably going to find the loop detector under these cars here. And knowing about the loop detector, you can know what is the density, how much are these cars packed between each other. And then comes a very, very famous traffic engineering study, and it is hot topic, and you might make lots of money out of it, because a life is important and very, very expensive. So traffic studies are important, but crash studies and safety studies, so another word for it is safety, is something really, really hot and important right now, because we want to reduce lives and injuries on the road. Before you build anything, and part of your TIS is having something called parking studies. Just figure out what is the demand and supply needed for parking. And when we build any new development, we need to add some parking to it, or figure out, will the street parking handle it? So if you, just a good example here, if you go to Charleston, you might notice that there is construction around the downtown library of Charleston. Why? Because it's old. But one other reason is that just going to this library and parking your car was a big problem. So they are now developing the new library, and they're having a new parking lot. So for them to finish this, they need to figure out, okay, how many cars will need to be there, especially we're in the downtown area. So part of the work here is parking studies, parking supply and demand, accumulation for parking, and there are ways to collect data for parking. I'm going to talk about this in class as an example. And then freight trucks and eddy trucks and boats and rail that collect freight. And here we have a very good example in West Virginia, which is coal. So coal is one thing that you need to carry from the mines to the points of distribution. So trucks here, so there's something called freight analysis and supply chains that we use. Also, we need data to collect data as well. And then comes transit studies. When we talked about buses, subways, anything related to transit, also they share the road with other cars. So this is part also of traffic. We need traffic data for that. Pedestrian bike studies, and this is kind of new with now the level of obesity around the world and the health problems. People are moving now to bicycle and pedestrians. And when we have a new development of the city, bicycles and pedestrians are one important thing for us as to develop. And lots of cities around the world are going to into this for active studies to have a master plan for pedestrian movement and another master plan for bike movements. We have bike paths, bike lanes, and also we have sidewalks and different facilities for pedestrians. They call this active transportation. Active transportation. Finally, when we have models, especially computer models, we need to collect data, all these kinds of data, to do these calibration studies. So when I calibrate any models, it might be math or it might be computer models, and that's the most important thing. And the models change from time to time because also traffic changes from time to time. So what are the different kinds of data collection methods? And we're going to talk about this in class on Wednesday. Before we start solving a question, we have 3 types of data collection. Let's first start with the first one. Is this guy here. This guy is holding some kind of a piece of equipment, and now with your cell phones and your iPads we can include this equipment, so we don't need to purchase specific equipment. It's much easier right now. This piece of equipment has some buttons. All you have to do is just tap when you see a car, and tap, you count cars, and this is called manual counts. The problem with that, it needs people, and people cost money and hourly wage to do that. We use usually students, we use low-income temporary workers to do that, and we need also supervisor to supervise these guys. So this is called manual studies. And then I'm going to go to the last one before I move to this middle one, fully automated studies. And we talked about this when we talked about ways to have permanent studies, things that are on the road. I'm drawing here loop detectors, or I have cameras. So they are fully automated and they are also permanent. Among them loop detectors and among them cameras. And they count 24/7. They're fully automated, no human intervention. You go to the DOT, you ask, okay, I want counts, especially average daily traffic for this kind of roadway or this kind of intersection, and they can give you the tables, and sometimes they can give you the road data, the feed from the cameras of this road, and you can do your own count. So this is called fully automated or permanent studies. And then comes something in between. And this is what we do, guys, in our project actually, and I'm gonna show you the equipment. Is that we put equipment, so it's manually, but it also uses some kind of technology. We have what we call here semi-automated, meaning that it needs some human interaction with it. Among them is something like you can see here, which is something called the pressure tubes, which are very simple. Some tubes, you might see this a lot on the road, that are nailed on the pavement, and they are attached to this box you can see here, and whenever a car passes it, it pushes the air, it has air inside, and it makes a pulse and it counts the car, and they have more than one to count also the speed, and can count more than one thing. It's an old technology but still used till now, and you probably have seen that. The second thing is cameras, radar. So there are different kinds of this, what we call here semi-automated. So it's both manual and we use some kind of equipment and automation. So these are 3 main types of counts. This one is used for permanent studies. These 2 are used for temporary studies, something that you cannot have all the time. And you can see these tubes on the road, they're there for a few weeks and then they remove it again. So for manual traffic, these are let's now just talk about it. So here we have, it's for short duration. For example, AM, PM, we cannot have people staying there for days, just a few hours a day. We use it for, we count how many people in the car. You have to have a human to do that. We do some classified counts, meaning that you need to know what type of vehicles on the road. We do it for intersections when we know who's going where. Turning, we call it turning movement counts. Speed, but speed can be in different ways now with the technology. we can directly find the speed. So we can ask people also to have the same speed gun that the cops have, and this is what I'm talking about. You might see the cops having this kind of equipment in their car, or this, and we have here speed counts. And also we can, and this happens also, this has to have a human, where you go there and figure out the travel time and the delay data by going on a car by yourself and doing that. So we have here handheld devices, counters, radar, meters, and things. Radar like for the similar to what the cups have, and we do a lot of things out of this manual counts. And then comes the I'm gonna solve a question. Is that sometimes, since we're dealing with humans sometimes make mistakes. They need a rest. They just quit finishing their work. They go and sleep. So we need to do some kind of interpolation for the times, the 15 minutes. Remember 15 minutes? We do it every 15 minutes. So when we have missing 15 minutes, we do some kind of interpolation. The missing time is the one before and after. So here we assume the same rate of flow happens for this missing time, and we just try to fix this. Y and X here are the times where they worked. Let's say they had a break for 3 minutes out of 15 minutes. So we just need to fix this is just fixing the time with the one before or after, or the one you have right now. Let's say, I'm going to give you an example in class, but very fast. Let's say that I want the volume for 15 minutes, and I will only count it for 10 minutes. So I'm just going to expand this 10 minutes between the 15 and the 10. That's how it works. So we can make out of the missing time periods. Also, when and this is the interpolation I was telling you about, or extrapolation, when I have two different 15 minutes, and I want to know the one that people were missing, or he slept, or he didn't count. So we do some kind of analysis for interpolation and kind of approximation to find these values. Then we talk here about the semi-automated traffic collection. So we have here what we call here the road tubes, and this, you can might see this on the road. We put tubes, and this is the control box. It gives a pulse, and we connect it and we chain it to the poles. We can also have, when we have two of them, knowing the distance between them, that's also going to be a speed trap, knowing the difference in time between the two pulses for the two tubes. And we can just go ahead and do counts ourselves to calibrate this equipment to figure out if it's right or wrong. It's portable, you can put it wherever you want. It just needs a little bit of time and experience to put them on the road. It's kind of dangerous, especially in the middle of the night. That's why experienced DOT workers do that. Then let's talk about permanent. Well, we talked about the loop detectors. So they are permanent detectors and sensors. They're attached to computer control stations. So they are also attached to what we call here the traffic control station in the middle of the city, or the DOT, and they figure out lots of things. You can see here there's an engineer in the office, and he figures out, and based on that he can write anything he wants in this variable signs to warn drivers that there is a crash, and you can see this a lot as part of our work as traffic engineers. So type of technologies, we use tons of technology. I just talked about cameras, but there are sound, some cameras are optical, vibration, laser radar, reflection of some kind of analysis. So here sometimes electromagnetic induction, which is the loop detectors we talk about. And we use to find count, speed, occupancy, and density. Several things we can do from these kind of counts. And then we use, so these are some of the pictures. This is what we call here a radar. It's like a suitcase you put on the pole, and it also creates some kind of an owl-like radar where it counts traffic. This is another kind of, you might see this a lot. It also creates this kind of imaginary field when there's a car that does a pulse. Cameras is another thing, and now with the technologies of detection, it can do the counts and figure out also what kind of vehicle it is by something like the face recognition on your phone. So these are the different kinds of technologies used for these permanent and fully automated traffic collection. We call it microwave radars. We use it to traffic signals. We use it to classify roads. something called video image processing. We use it especially in cameras, and that's a new technology. It's a hot topic as well. Traffic data collection methodology. So here we have cell phone technologies right now, and this is the big data I was telling you about. Our cell phones and smartphones collect our data 24/7. So this is something that you see in your Google Maps. So some other data we have to collect sometimes, and this happens especially when we talk about people, when I ask people. So we do something called interview studies, and we have different kinds of interview studies. One of them is the home interview studies, where we knock on doors and figure out where are you going, where are you coming from, where do you work. We can get this studies. It's like similar to the census data, so we do something similar. So we use it for more demographic information, people, their information about income and how many people, and also important for us is transportation information. Where are you coming from, where are you going. It's costly, takes time, takes people to collect data, and we have some issues with legality and safety and privacy as well. So that's why we use what you call here sampling. We do some samples exactly like they do in the census, but in a smaller sample way. And then sometimes, and you might find this a lot of traffic, especially in traffic signals. We do interview studies. And again, we go there and ask the driver very fast. We're doing a study. Where are you coming from? And we do this. It's during the trip. It causes some kind of disruption. That's why sometimes we do it in a signal. Sometimes you just go there and count how many people in the car. It's very short. Sometimes you need the help of the police. We do it a lot in red signals, so we don't interrupt the traffic. And by this, guys, we finish our first video in this kind when we talk here about traffic signals. We talk here about traffic data. Chapters 9 and 10 in your textbook has a nice reading about it. I suggest you guys read it. And on Wednesday and Friday, I'm going to tell you in class right now what we will be doing about this. So thank you guys, and see you in the next video, and have a great day.